So in this tutorial, we'll talk about finding the solution for this non-homogeneous state equation. What is a homogeneous state equation? It is x dot is equal to ax. So we can see here that we are having a forcing function u of t. So this particular equation will have two solutions. One is zero response and the other is particular solution. Particular solution particular to the u of t, the forcing input. If u of t changes, this particular integral this particular solution should change, but zero response is independent of input. So if we know these two solutions, then we know the complete solution of this particular non-homogeneous state equation. So let's see how to go forward and solve this equation. This can be solved in two ways. One is a completely mathematical approach, and the other is through intuitive physical significance based approach using the properties of LTI system. So first one is mathematical, second one is using the property of LTI systems, linear time invariant systems. So first we go with the mathematical approach and see what is the solution. It is straightforward method. So I'll be going through some steps which will eventually lead me to the solution. So basically I have brought the ax part in the right hand side to the left hand, and then I have bu. Now I multiply with e power minus at on both sides, then it will give me e power minus at into a into x is equal to e power minus at into b into u. So this can be written in d by dt of e power minus at into x is equal to e power minus at b into u. So after multiplying with e power minus at, we were able to write the left hand side as a differentiation of product of e power minus at and x. So let's now try to integrate this particular equation and get the solution. So when I multiply with dt on both sides and integrate, then what happens? So d into e power minus d of e power minus at into x is equal to integral, definite integral 0 to t and e power minus 8 tau. I'm changing the variable from t to tau because it is inside the integral. So u of tau d tau plus some constant c which will depend on initial conditions. So from the fundamental calculus theorem we can cancel out these two. Then in order to find out the value of c, we should go and see what are the initial conditions. So at t is equal to 0, this integration will go to 0 because it is going from 0 to 0, it will not enclose any area. So that's why we have e power minus a0 into x of 0 is equal to c. So basically my initial conditions is nothing but x of 0. So I'll rewrite this equation again as e power minus at into x of t is equal to x0 x of 0 plus integral 0 to t e power minus a tau b u of tau d tau. So let me just multiply e power at on both sides so that we can end up in the solution that we are expecting. So x of 0 into e power at plus e power a of t minus tau b into u of tau d tau. So this is the first part of this tutorial. In the second part, we'll discuss how to arrive at the same solution but from a different approach. Thank you.